Okay, good morning class. So today we're looking at exponents. So this textbook that we are currently dealing with does not cover exponential equations. However, it is required for you guys to do it anyway. Okay, so this is from the Mind Action series. This is for exercise. Okay, that's why I'm just putting the hashtag there because it's a different textbook than what we have been referring to all the time. It's on page 63 and the exercise 3 is on page 64 there. Okay. So exponential equations, in exponential equations, the exponent is the unknown. For example, the equation 3 to the x is equal to 9. See 3. So what is x equal to? 3 to the 3 is 27. 3 to the 1 is 3. It's 2. So x equal to 2 in other words. Okay. For example, the equation 3 to the x is called an exponential equation because the unknown variable is in the exponent. Clearly the solution to this equation is x equal to 2 because 3 squared is equal to 9. Getting the basis on both sides of the equation to be the same, then equating the exponents will solve the equation as follows. So what they did was they took 3 to the x is equal to 9. So we get the basis the same for the exponents to be equal. So 3 to the x equal to 3 to the 2. You see the bases are the same. So therefore, x is equal to, you understand? So it says right, 9 as the base of 3, equate the exponents. Alright. So let's look at example 13, which is on page 63. Let's look at the first one. So what's the first thing we need to do? First, to make the bases the same. Make the bases the same. So 9 can be written as 3 squared. So what can I conclude? Therefore, when bases are the same, exponents are equal, not so. So therefore, 2x is equal to 2. You see here? The bases are the same. So which means to say, the exponent is going to be. Can you see that, people? So if 2x is equal to 2, therefore x is equal to 1. And the nice thing about this, you can test it. If I put 1 in here, what is 3 to the 2 times 1? What's 2 times 1? 2. And 3 squared is 9. You guys see that? Am I moving too fast? No. Let's look at the next one. We got 2 to the exponent x minus 4 is equal to 1. To the x minus 4 is equal to 1. So what did we say? We need to make the bases the same for the exponents to be equal, not so. So in other words, this base must also be 2. So we know that 2 to the x minus 4 is equal to 2 to what exponent will give you 1? 2 to the power 0 is. So anything to the power 0 is 1. So later on, if I got 5x minus 6 is equal to 1, am I going to make that 2 to the 0? No. Then what will we do? Make it 5 to the 0. Why? Because we want the bases to be the same. So if the bases are the same, what can we do? We can equate the exponents. We can make the exponents equal. You guys understand? Alright. So what can we conclude from here now? Therefore, bases are the same, exponents are equal. So therefore, x minus 4 is equal to 0. You guys understand? So what can we do now? So you get 4 over the equal sign. So x is equal to What's x equal to? 4. What's wrong with you guys today? You see, sports is not good for you. No? I had you yesterday, last week, you guys, half of you were sleeping. Now, today you're awake, but your brain is sleeping. No? So nobody's talking back to me. Right, C. This is 5 multiplied by 5 to the x equal to 125. So what do I do first? Sorry? Make the bases the same. So 125 can be written as what? There's actually two ways of doing this, okay? 5 cubed. When you're multiplying and bases are the same, what do you do with the exponents? You add it. So what's the exponent on the first 5? 1. So in other words, this will be 5 to the exponent 1 plus. Can you see that, people? So when the bases are the same, exponents are. When bases are the same, exponents are equal, yes. So therefore, one plus x, yes, equals 3. Now what? X is equal to 2. Okay. I said there's another way you could have done this. If I had 5 multiplied by 5 to the x equal to 125. Instead of multiplying this and adding that exponents, what I could do is I could have divided by 5 first both sides. Why? As to get the base with a variable exponent on its own. Can you see that, people? So by doing that, that 5 cancel. So 5 to the x equal to what's 125 divided by 5? Huh? 125 is 25. But 25 is the same as 5 squared. So 5 to the x is equal to 5 squared. When bases are the same, exponents are equal. So therefore, x is equal to, which is the same thing. Okay, that's the nice thing about mathematics. As long as you're applying the rules of mathematics properly, you should get the same answer. Okay. Do you guys understand? Okay, any confusion so far? Okay. Until you get the test, then it's a different ball game. No? People, let's look at D and E. D. In D we got 5 to the exponent x is equal to 1 over 25. What do we have to do first? Get the bases the same. The idea is to get the bases the same. If the bases are the same, the exponents are equal. We can equate the exponents. So that is fine, 5 to the x. However, 25 can be written as what? 5 squared. Not so. So that's 1 over 5 squared. So can I make that equal to that? No. So there's a denominator at 5, there's a numerator here. To get at the numerator, I need to bring this up. Okay? So I have 5 to the x is equal to 5 to the minus 2. Can you see that, people? Now what? Bases are the same. Exponents are equal. So therefore, x is equal to minus 2. Okay. Hafsa? And we can test it again, people. Okay, let's just pull a calculator up here. Of course, you guys are not going to allow it to be used a calculator in the exam. I'm just going to show you. You've got 5, the exponent negative 2, is your 1 over 3. Okay. People, E. Now you see, 2 is already in the products of his prime factors, not so. So you're going to leave it as 2. So what is the exponent on this 2? 1. If there's no exponent, it's a 1. So that will stay 2. 2 to the 1. So we're going to try and get this as a base of 2 as well. So what can we do here? Then change 4. 4 can be written as what? 2 squared. So it's 1 over 2 squared raised to the exponent. Now what? 3x squared to the top, numerator. But it will now be written as what? 2 to the negative 2 raised to the x is equal to 2 to the. Now what do we do? Times the exponents. Yes. When something raised to I exponent, we multiply the exponents. So that would be 2 to the negative 2x is equal to 2 to the exponent. Now what do we do? When bases are the same, the exponents are equal. So therefore, negative 2x is equal to 1. So how do I get x on its own? Divide by negative 2 both sides. So x is equal to negative 1. And of course you can test it again. So it'll be open brackets a quarter to the exponent negative half. Then the answer of 2. Okay. So with any confusion, okay, so from your textbook you guys can do exercise 3, which is on page 64. We are going to do the first column, and then your second column will be your homework. Okay, I'll stop the video at this point.